Hi, my name is Miss Logan, and today we are looking at probability. Appreciate you in advance for hanging out with me. Hope you enjoy that. I am standing at the park because I'm representing that park. This is the first school that I taught at, and love them, love them, love them. We are going to be looking at probability like I discussed. Basic, just the beginning. Looking at with replacement, without replacement. We'll be working with cards, flipping coins. We're going to do an abbreviated deck and the full deck. So please take notes, especially if you need to. You might have this and be like, I understand, I don't have to do all that. Cool, love it. But the last assessment is going to be more written than not. So it's not multiple choice. You may want to write some things down. There are breaks already in the lesson, music, dancing, just an opportunity for you to turn your brain off while we're resting in between sessions, because we are going to go straight through. And I ask for your undivided attention during the instruction. That's what the breaks are for. This is your moment to get in your phone, go to the restroom, do something other than be in that math. But when we're in that math, I'm asking for 100% of your attention so that we can make sure that you actually understand the concepts. Thank you so much for your time. Thank you for learning math with me, and I hope that you enjoy it. Have a wonderful session. I am troubleshooting because I made a mistake yesterday and I did this wonderful lesson. I was prepared and all that good jazz, and it had no volume. So we're going to talk about probability of an event, how to find the probability of event, and we're going to use a number cube. Now, most of us know this as a die, and this is not the traditional one. So this is not the one that you would see most likely. I'm a math teacher, so I'll be having all types of stuff around the place. So let's talk about probability. So the probability of an event is defined that, so P of E equals M, which is kind of the number of ways of whatever you're looking for, divided by N, which is the total number of equally possible ways. So we're going to summarize that today as part over whole, the part that we're looking for over all of the values, the probability of the event. So we're looking at this die. So let's look at what we see. So this is the number set. This is going to be the values on the, hey, I'm waving at my people on IG. How you doing? Appreciate you, appreciate you. Hopefully I've got some people on Facebook. So we have a 5. Just wanted to say hey, and I'm getting back to that math. Then we're going to flip that. We have a 6, we have a 7, we have an 8, we have a 9, and we have a 10. And I believe that that represents all the sides of this number cube, also referred to as a die. And we're not going to be playing with this today outside of just learning a little bit of probability as a mini lesson. So after we have looked at all the values on the number cube, we're going to determine how many sides we have for our figure. So the number of sides we have, which we already discussed, is 6. So now let's look at the probability. And I did post this card, and if I haven't, then I will post it on Organized Chaos 180. But these are the examples that we need to look at because we're talking about the part over whole, right? And we're looking at the probability of, let's look at the probability of, if I just randomly was playing with this die, what is the probability that I would get? All right, 8 came up first. What is the probability that we would get an 8? Well, we would look at the definition, which is part over whole. How many 8s do we have? Well, we've written out our number set. We only have 1 8. So the part would be 1. So the probability of 8, there's 1 8 out of 1, 2, 3, 4, 5, 6, and we've already written that down. 1 over 6, so the probability of rolling an 8 would be 1 over 6. Let's look at the probability of 5. Now, I'm just going through the answers at this point because I really want to test the volume and make sure that I'm not spending a lot of time and I can't hear anything. So the probability of 5 would be, how many 5s do we have? We have 1 5 out of how many sides? 1 over 6. And this is in preparation for playing cards. We'll have more values to work with when we're dealing with that. Let's look at probability of 6, probability of rolling a 6. Now, I'm rolling it and I did not get a 6, so let's go to 10. How about that? Probability of 10, there's 1 10, and there's a total of 6 values. Now, let's go back to probability of 6. How many 6s do we have? There's 1 6 in our set, and there's a total of 6 values. Now, probability of 7. There's 1 7 in the set. Oh, I should have put a comma in between those two, my bad. And there are 6 values in our number set total. And then what is the probability of 9? And that is 1 9 and a total of 6. Now, that should add up to be 1 because 100% represents all the sides of this number cube or dice. And that's really all I wanted to cover today, just really, really basic. So I just need to get this story off my chest so I can move on with my day. I was taking my mom some Girl Scout cookies because it's Girl Scout cookie season. What? And she likes the caramel delights. I like the thin mints. But anyway, hey. So I take my mom these cookies, and she's painting one of her houses, and she's and there are people in there painting with her. And so one of the young men, which I met both, introduced both, is like, how much you sell your cookies for? And I'm like, I don't sell any cookies. So I don't sell cookies. So I make it clear. No, I purchased some cookies, and I'm bringing my mom. I'm bringing my mother some cookies. So she and I continue to converse. I get ready to leave. And on the way out the door, he asks what I have in the car as far as more cookies. Now, I thought we already crossed that bridge. I'm not selling any cookies. So I say, no, I don't have any cookies. And I'm nice about it. I don't have any cookies in the car. Now, the truth is, that was a lie. I did have some cookies in the car, but I didn't have any cookies for him in the car. So I was a little offended earlier, like the nerve. I said I didn't sell no cookies. I'm not selling no cookies. I have no cookies for you, homie. And then I realized it's just that, I don't need to act like that. I don't need to act like that because shoot your shot, But he didn't shoot no shot. He just was, I don't understand what was happening. But if it had been the right person, then I would have had some cookies in the car. So I had to think about it from that perspective. And it just was funny then. So I could not be mad about it. So now I can move on with my day. And that was my little funny story for the day. I was a little bit annoyed too, like the nerve of this dude. But, I don't know. Maybe he was interested. Maybe he wasn't, but he was getting on my nerves. However, thank you so much, Trap King 447 for joining me. That's all I had to say. I just wanted to talk about my day because I had a weird moment. Appreciate you. I'm about to be out. Have a wonderful remainder of your day. Bye. So let us get started. So 7 is the lowest number on this number cube. What is the number set for this number cube? So last week we did discuss, and welcome back to everyone. Last week we discussed what a number cube was, and that's a die. Hopefully you've seen a regular one. If you haven't, I don't know. Some people have not had the opportunity and some people have, but this is a non-traditional one again. I have my resources around, and this is not the one that you usually see. So if 7 is the lowest number, and we know that a number die has, we know that a number die has 6 sides. We'll come back to that. We'll just go through it right quick. 7, 8, 9, where's my 10? 10, 11, and, did I show 11? I was moving too fast. 11 and 12. So hopefully you already knew that. Hopefully you were with me, and that's our number set. So just as a reminder, last week we talked about the probability of event. That's what that means. P for probability, E for event is equal to, and we kind of summarize that to the part that we're looking for over the whole. So we may not know at this point because we're going to roll and find randomly what our numbers are for our 2 examples that we warm up with. But we do know that the denominator should be, and the denominator meaning the bottom of the fraction, the bottom part. The denominator is going to be 6. Why? Because we have 1, 2, 3, 4, 5, 6 values on this number cube. So let's go ahead and figure out what we're looking for first, the probability of an 8. So the probability of an 8 would be what? Now a little How many eights do we have? Well, we have 1 8. And how many sides do we have? We have 6 sides. And then let's roll one more example just to warm up real quick. The probability of a 7. And the probability of a 7 is, how many 7s do we have? We have 1 7 out of our 6 sides. So that is the probability of those two values. Now, that is not what we're working with today. Again, there was a picture posted. This is probably not the same order that you saw online, but if you did not have an opportunity to look at that, then this is what we're working with. So we're going to be finding our probabilities, and there are examples. It was posted as well. So what I'm going to do is I'm going to pull this back up because I haven't given enough time for you to really look at that. And I'm going to change my paper for a moment so you can look at, just based upon what we just discussed, here are the values that we're looking at. And I'm going to discuss what's what if you've never seen or played cards, because not everyone has actually played with cards. So now I did this by hand, as you can tell, and this is my rendition of a spade. So we're talking about this card. This is a spade. So this is my rendition of a spade. This is my rendition of a heart. And so that will be a heart. And I'm building this language because I'm going to build on this unit, and next week, I believe, we'll be working with the full deck and the denominator with that. So this is a diamond, and just as a reference of an example, this is a diamond, and that's what we're talking about. And then finally, this is my rendition of a club, and this one is a club. Just so you know what I'm talking about when we actually start working this, which is going to be very shortly. I just want to show this to Facebook because I don't know if they saw that, and I didn't show it earlier. Let me see if I can get my lights to cooperate. There we go. That's what we're working on, and we're about to move into that shortly. Another thing, really quickly, before we move on, next week we will not be on this channel. Next week we will be on a different channel because I am transitioning to a channel with just my math videos. But let's get started. First of all, what do we need to know? We know that we know what we're looking for. Like, I know what I want you to find the probability of, but what? Hey, I think that's my brother. What's up, bro? Okay, focus. But how many cards do I have? I don't know what my denominator is. So I know that I have probability of some events. I know I need to do part over whole, but what I need to know is what is all of the events. So the first thing I need to do is count my cards. That's what that means. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. So I have a denominator of 11, and we know that moving forward. So, okay, I believe we can go into example A. So example 1A. So example 1A is the probability of a spade. So then what do we need to find out? Hopefully you're with me and I'm not moving too fast. So then that means what we need to know is how many spades we have in our hand out of how many total. So how many spades do you see? Hopefully you are with me and you said 4. So then the probability of a spade would be 4 over 11. And let's now move on to B. What is the probability of a diamond? If you are with me, hopefully you're ahead of me and you already see that there are 2 diamonds over our denominator of 11 cards. Now let's move on. So we have the probability of a heart. How many hearts do we have? 1, 2, 3 hearts out of our 11 cards. So the probability of a heart is 3 out of 11. And then finally, the probability of a club is 2 clubs out of 11. So we just want to check our work real quickly. We're going to do a quick check to make sure that that equals all of the cards that we have. So we're going to do 4 over 11 plus 3 over 11 plus 2 over 11 plus 2 over 11. So this should represent all of the cards, or 100% of the cards that is in my hand. So 4, 5, 6, 7, 8, 9, 10, 11. So my because we have common denominators, and I'm not going to go too far into that because that's not what we're here for today, but because the denominator is the same in all of our fractions, we can add the numerators. So that becomes 4 plus 3 plus 2 plus 2, which gives us 11 over 11, which does give us 1, which is all of the values that were in our hands. So we know we have actually accounted for every card, and we have found the probability of all of the suits that are in our hand. And next week, we're going to be moving a little farther because that's all I really wanted to discuss. I am building on probability in a really quick fashion. Hopefully, you were with me. Like I said, next week we will be in a different place. We will be looking at the full deck a little further, and I think I will actually build on a different concept. At that time, I wanted to I'm promoting my channel. I am promoting this for parents who need help with math, students who need help with math. It will be math only. It is a work in progress. So there will be some things that are relevant today, and there will be some things that you might be looking for. So as I get feedback and follow up from my audience, then I can build. And I'm working, so it's a lot going on, but I am working. So for those of you, thank you so much for joining me. Hello again. And now that we have discussed, let's see, we've talked about rolling dice, we have talked about pulling cards. We're going to look at that full deck. Now we're moving into looking at that full deck. So, and changed it up a little bit. I'm now representing Westlake High School. That's the last school I taught at. Love them, love them. Yeah, so we're getting back in there. We're looking at that full deck now. So we're taking a break. That's where we are. Directly after this, you're going to see a short video that's going to give you the homework going into the next video. And then after that, you'll have like a 7-minute video, which is funny. It's me totally out of shape. But it is, again, a moment for you to take a break, take a breather, work on that homework if you have not already done it. Just a few problems, just working on, you practicing that probability before we go into looking towards the whole deck and how to do the math that way. So thank you for hanging out with me. Thank you for staying this long. Let's get it. Let's get this math. I know, hopefully you understand. If not, rewind, try again, come back. We are going to keep going. All right, let's get this math. The odds, part 3, full deck, no jokers. Hope to see you there. And if you don't make it, then you can always check us out on TC Homework Help 180 on YouTube. Have a great one. Oh, I'm live. Welcome back. Nobody's here, but welcome back. So yeah, I did not do both directions. I'm going to do the other direction this time. So this time is for you. I press shuffle. The title is Wait, Don't Rush. And shuffle in 5, 4, 3, and yes, I'm tired. 2, 1. Oh, welcome. Hi. I'm just flowing. I don't know what it's gonna look like, to be honest with you. I'm tired. And the wrong song. Sorry. Now starting. I'm starting with wait. Oh. Ooh. My impeccable rep does. Yes, I need my towel. I'm mad. Let them wait. See? Let them wait. Yeah! Let them wait. Russian me, you Russian excellence. Let them wait. Let them wait. Oh, man. Oh, that's my song. Oh. Mm. Don't rush. Don't slow touch. Oh, what's the other one? What's that? Busta Rhymes. sorts. Appreciate you for real. Oh, that's it. Oh, that was like such a good workout. Thank you so much for joining me. And yes, I'm tired and it's been like 7 minutes. That means I'm so out of dancer shape. A lot more to come, a lot more practice. Appreciate you for joining me. Have a good one. We will go over all of those things. And we are starting right now. So, welcome to everyone who has joined us for the day. We are TC, I am TC Homework Help, TC Homework Help 180. We are still live on Instagram. My apologies for that interruption. We are back. So, let's just start with a funny story. Let's start with a funny story. So that hopefully you will never forget the number of cards in a deck. So back in the day, and I can say back in the day because I'm 40, and when I was about 10, back in the day, there was this game called 52 card pickup, right? So when you played 52 card pickup, it wasn't necessarily fun. So what would happen is someone would come up to you and say, hey, you want to play 52 card pickup? And my little 10-year-old self said, yeah, I want to play 52 card pickup. What's that? And what they would do is they would take, now this is not the full deck, this is just one of the suits. We've talked about the suits before now. This is just one of the suits. This is the whole family of the spades. And so I'm just going to demonstrate with that. But what they would do is just take the deck and they would do that number. They would do this number. And all the cards would fall over the place. And they would say, pick it up. So that is 52 cards pickups. And if you could imagine my little 10-year-old face as I am looking at this person who is so serious about you picking up the 52 cards. And I never forgot from that day moving forward that there are 52 cards in a deck. And that is going to be the necessary information for us to complete this lesson today. And we're going to be brief, but not too fast. So again, today we are doing probability. We're looking at what are the odds, part 3. Full deck, no jokers. So the jokers are here because when you pull out all of the cards in the box, there are 54, but that is not what we're working with. When any assessment, any test, your denominator should be 52. So hopefully after that story, you can think about my face as I was picking up those cards and laugh and remember that, oh yeah, I picked up all 52 because the person who asked me to play, and I agreed, was expecting that I picked those cards up. Picked it. That's such bad English. I'm getting it together. Welcome back. Welcome back. All right, so let's look at the warm-up. We've been talking about probability for the last couple of weeks. So the probability of the first one, we know we've been working with the number cube. So hopefully we recall that there are 6 sides to a number cube. So the probability of a 2, we would consider how many 2s are there on a number cube? Well, we just so happen to not get we have 1. So there's 1, 2 on a number cube out of the possible 6 sides, which makes the probability of 2 1/6. And now let's look at number 2, just another refresher because we have not actually talked about flipping a coin, but we have talked about probability several times. So same thing, part over whole, part over whole. What are the part that we're looking for? What is the total number of options that are possible? Well, there is 1 head on a coin and there are 2 sides of a coin. So the probability of flipping a head, if you were tossing a coin, is 1/2. All right, so let's get into the lesson. And as we reviewed, there was a little bit of homework, so we can just go through that really quickly. So last week we discussed the 4 suits, and last week we looked at probability of a set of cards, and I took a random set from the full deck. Today we're working with the full deck when we're looking at probability, but that's not exactly what we did last week. So we do want to review some things. So I've pulled out the whole deck again because not every person has ever played with a deck. Just to go quickly to show all of the cards in each suit. Now I'm not going to do each suit. We see here that there are 1, 2, 3, 4 suits. And so I'm not going to do each suit because that's not necessary at this time for me to do that. But what I am going to do is I'm going to count for you one full suit. And so you begin with the ace. That's kind of your one. Now, ace is the highest card when you're playing spades, and that's another conversation for another day. But that is the one of the suit. And then there's 2, 3. Oh, I'm out of order. I was playing. Sorry. 4, 5, 6, 7, 8, 9, 10. After the 10, the jack, the queen, who is stronger than the jack, and then the king, who is stronger than the queen. So with respect to how many cards are there in each suit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for future reference, for any assessment, there are 13. We began with 13 out of a total of 52 because we've discussed that earlier today. Now, because all of the suits are the same, as far as the same number of cards in each suit, then there we go. My apologies. Then we want to go to the probability of a heart. So the probability of the heart would be equivalent to the probability of a spade. There are 13 hearts in the deck out of a total of 52 cards. The probability of a club. There are 13 clubs out of a total of 52 cards. And the probability of a diamond is 13 out of 52. So yes, in our deck, we have a total of 52 cards. Each suit is represented by 13 different cards. And those are the numbers that we're going to be working with. All right, we are back. All right, so let's move on. We have reviewed, we've warmed up. I'm adjusting my camera. And let's move on to with and without replacement. So at this point, I'm going to take the full deck. And I'm just going to shuffle in the spades. I'm shuffling the spades because I want to pull some random cards for our examples. That was a terrible shuffle. It really was. What is our time looking like? We've been about 10 minutes so far. Hey, Facebook again. Thank you for joining me if you're on here. If you're not, you can always view us on YouTube. And I really appreciate your time. Just trying to get an idea of the type of instruction that will be on this channel. That's what this is about, getting it out there, getting the word out there. All right, so let's look at the probability of, I had an agenda. So now we want to talk about with and without replacement. That's what we're talking about today. So we want to talk about probability with replacement, meaning we put the card back. Put the card, the item back. So let's jump into that for a second. So let's say probability, we're going to pull a card. I'm going to pull a card randomly. So if I pull a card randomly out of the deck, I get probability of 2 of clubs. The probability of 2 of clubs. I pull the 2 of clubs, and we want to know the probability of a 2 of clubs. Well, how many 2s are in the deck? We know that each set has 13 cards. We know that each suit has a deuce, a 2. So that means how many deuces or how many 2s are in the entire deck? Well, there are 4. 1 for each suit, and that is 4 out of how many cards? A total of 52, and that's why we began with the denominator. Now, if I put this card back, boom, the question would be, what would be the probability of pulling that card? Well, at the end of the day, so with replacement, I put the card back, so it's now still a part of the set. If I were to try to find the probability of a 2 of club, again, the theoretical probability would be the same because there are still 4 2s. Well, I made a mistake. I'm sorry. This one should have been just a probability of a 2. The probability of a 2. Now, the probability of a 2 of club is there's only 1 club. I made a mistake. I apologize, and I'm going to correct that. There's only one club out of the 52 cards, and the probability of a 2. So the probability of a 2 is still 4 of 52. So let me go back and clarify and clean all that up. I apologize, I made a mistake, and I want to correct that right now in real time. So what I should have asked in my first question was simply a probability of the 2, not a 2 of club. The probability of a 2 is a 4 over 52 because there are 4 2s in the entire deck. Now, if I was looking for the probability of a 2 of clubs specifically, a 2 of clubs specifically, which is not what I wanted, but that's what I said, then that would be 1 out of 52 because there is only one 2 of club in the deck. Now, if I'm looking, that was just that correction because I made a mistake before. So 4 out of 52 being the probability of 2. Now, if I put that back, so I replace it in the deck, and I look again for the probability of 2, that is going to be the same. There are still 4 2s in the deck of 52 cards. My apologies. Let's do another example since I made a mistake. Let's look at the probability. We're going to pull a random card, and I'm not going to pay attention to suit in this moment. We need another replacement. So let's look at a jack. So the probability of a jack equals how many jacks are there in the deck? Well, there are 4, 1 for each suit, and the probability is 52. So if I put that back, so I put the jack back in the deck, I don't know where it is, and I'm asking what the probability would be. It would be the same as it was before because nothing has changed. There are still 4 jacks, there are still 52 cards, and this is what I'm looking for. Now, let's say we looked at the probability of a jack. We pulled a jack, but we did not replace it. So this is without replacement. What happens? Well, if I took out the jack, boom, this is not the jack, but let's say that were. I took out the jack. What happens is one of the jacks is now out of the deck. So how many are there remaining? Where there are 3 jacks remaining in the deck, and there are only 51 cards in the deck because I took a card out of the deck. So replacement will change your denominator, and it may change your numerator. Let's do another one. How many minutes are we? About 15. Let's do another one because my first example was not that clear. So we're going to go a couple of places. Let's pull a random card. We are going to go without replacement first so we can look at it. So let's look at randomly. We've got a 7 of diamond. Okay, so we pull a 7 of diamond. So what is the probability of a 7? So how many 7s are there in a deck? Well, there are 4 7s in a deck. And what is the probability? How many cards are there in the deck? There are 52 cards in the deck. So the probability of pulling a 7 is 4 out of 52. Now, let's say we do not replace this card. So I'm not putting it back. It's going to stay right there. What is the probability of a 7 now? Well, at this point, I have to think about, I've taken a 7 out. How many more 7s are there in the deck? Well, there are 3 7 remaining. There's the 7 of spade, there's the 7 of heart, there's the 7 of club. There's 3 7s remaining. So if there are 3 7s remaining, and how many cards are remaining? I took one out. We know we had 52 cards in the deck. We now have 51 cards in the deck. And that would be the probability of a 7 without replacing the original 7. Now let's look at, we still put that 7. Let's look at the probability of a 4. Let's look at the probability of a 4 without replacing the 7. So, okay, we didn't replace the 7. How many 4s are there in the deck? Well, we haven't taken any 4s out. So there are still 4 4s in the deck. And we know that there are 52 cards in a deck. We do. However, we took one out. So at this point, our denominator is 51 and not 52. So in this moment, Although I took that card out, it did not change the numerator, but it did change the denominator because we don't have 52 cards. Even though we started with 52 cards, when we took out that 7, it still impacted the denominator because I have one less card in my hand to pull from, which changes the probability of that value. Beautiful. You did it. You finished. You finished. Congratulations. Clap it up. Pat yourself on the back. You made it through. You've now looked at probability, rolling dice, probability, flipping a coin, probability with and without replacement. You are cooking with gas. And yes, what? We in that outdoor kitchen. I want y'all to check out my homeboy. You know, he stay around here. Next, we have an assessment. Now, it is not multiple choice. It is not digital in any way. What's going to happen is after this video plays, there will be the questions that you will need to answer. So I would encourage you to pause and write those down, or just answer them. You know, you don't have to write them down because you may be able to just go through them. I'm going to review what you will use to answer those questions. Only the things that we've already discussed. So a penny, I didn't bring one, but a coin, a penny. You also have red die. This one, the lowest value is 1. We know how many sides are on the die, so we know what to do. You have the green die. The lowest value on this one is 5. You know what to do. The white die, the lowest value on this one is 7. You know what to do. And then this is the set that you'll be using. Is that all of it? Yeah, boom. Let me make sure that ace of hearts, you can see it. This is the set that you'll be using to answer the questions. Again, for the next slides, you'll see the answers, not the answers, you'll see the questions, and you're going to use this set for the partial set. Now, for the full deck, you're using the full deck, no jokers. And so remember that. Remember my 10-year-old self in my face when I played 52 card pickup. We know what that denominator should be when we're talking about the full deck. So good luck. Test yourself. Trust yourself. What will happen is on TC _ homework help 180 on IG, you will be able to find the questions again. What you will see is the slide of the cards, the dice, the penny, so you'll know where the questions are. The questions will be next. After that, the answer choices will be there, and then after that will be the key. So if you miss 1, what your grade will be. If you miss 2, what your grade will be, so on and so forth. So check your own answers. Thank you so much for joining me. I hope that you enjoyed yourself, and I definitely hope that you learned something. Rewind if necessary, pause as needed. Appreciate your time, and have a wonderful remainder of your day. Thank you so much.